In this example, we want to find the maximum and minimum values of f of x, y, and z equals y squared minus 10z, subject to the constraint x squared plus y squared plus z squared equals 36. All right. And so here, again, we've got x, y, and z have to all be greater than or equal to 0. That's not true. Sorry, they can't be less than -6. And they can't be any bigger than 6. Okay, so we've bounded those guys. Next, gradient of f is equal to lambda times the gradient of g. So we'll write it out as our various equations. So in terms of x, we've got gradient of f with respect to x is 0. So that's equal to lambda 2x. With respect to y, we've got 2y equals lambda 2y. And with respect to z, we've got -10 is equal to lambda 2z. We also have x squared plus y squared plus z squared equals 36. So we need to satisfy all 4 of those equalities in our answer. Now, an important thing to note here is that because the left side of equation 3 is -10, we can't have a solution of lambda equals 0 or z is equal to 0. So let's write down here lambda is non-zero, z is non-zero. Okay, those are super important. In particular, lambda equals 0 would have been a solution we would have found on equation 1. So that means that because lambda can't be 0, that x has to be 0. That must be a part of every solution. From equation 2, we get lambda 2y minus 2y equals 0, or 2y lambda minus 1 equals 0. So y is equal to 0. Or lambda equals 1. Okay, so we can work with that. Let's work with our third one here. So we've got our third equation is -5 is equal to lambda z. All right, so if lambda equals 1 from here, that tells us that z is equal to -5. Okay, and so we have an equation where x is equal to 0, z is equal to -5, and so y has to be what remains in the third equation. So we have y squared plus z squared is 25 equals 36. So y squared equals 11, or y equals plus or minus root 11. So that's when lambda equals 1 from here. Now, if y is equal to 0, then we also know that x is equal to 0, which means z from the third equation is equal to plus or minus 6. So our possible solutions are x equals 0, y equals root 11, z equals -5. That's our first equation here. Next, x equals 0, y equals negative root 11, z equals negative 5. Third one, x equals 0, y equals 0, and z equals 6. And x equals 0, y equals 0, z equals negative 6. Our function value at these 3 points, at the first point, 0, root 11, and 5, negative 5, we get our f value is 61, plugging it in here. When we plug in the second point, we also get 61, right? The symmetry in terms of y's and z's will guarantee us that. When we plug in the third point, we get negative 60. And when we plug in the fourth point, we get positive 60. So our maxes occur here. Our minimum occurs here. And our third point is just an extra point.